Hey guys, I'm back, and I have to say this is probably one of my favorite sections because I love anything to do with geometry and formulas and all of that stuff, because all you gotta do is plug the stuff in and then push the buttons on the calculator. But anyways, here we go. We're starting with 10.4. We're talking about area and circumference. Okay, so this first one we're going to start off with is just talking about area of a rectangle and area of a square. All right, so area of a rectangle, we use length times width. We have our length and we have our width. Area of a square, we're going to do side squared, which there's the length of our side. All right, here we go. First problem, it says find the area of the path, then determine how many bricks are needed if for every square foot the path requires 4 bricks. Well, let me set the stage of our path. So our path looks like this. And these are all right angles. Let me label some stuff. So we've got 3 feet here. This is 13 feet, 6 feet, and 3 feet. So first of all, I want to find the area of the path. So there is no special formula for this odd shape. So I'm going to cut this into 2 shapes that I am used to working with, which would be 2 rectangles. So I have the first rectangle, I'm going to label it number 1, and this is going to be my number 2 rectangle. So the first rectangle's dimensions, I'm going to draw it out here. The dimensions we can see are already 13 feet by 3 feet. So I'm going to use my formula, area to length times width, and we're going to say 13 times 3 and get a grand total of 39 feet squared because we're talking about area. So then I'm going to come back over here and I'm going to say, okay, this is 39 feet squared. Now I'm going to look at the second rectangle. So I'm going to try to draw right on here its dimensions. But what I notice is I can't label this side as 6 because this whole side, 6 is only from here to here. I need from here to here. So I have to look across and say, wait a minute, this little dotted line is actually 3 feet. So 6 plus that 3 gives me the side of this to be 9 feet. So then I add that 9 because that's what's going to be important to me right here. And then we're going to use the formula, 3 times 9. And we're going to get 27 feet squared. So I have the 2 rectangles by themselves. So to find the sum of the area of this whole shape here, I'm going to have to say the total area would be that 39 plus 27 gives me a grand total of 66 feet squared. Remember, with area, we're talking about square units. So whichever unit they give us, this one is feet, so it's going to be square feet. Now, that answers the first part, find the area of the path. But now determine how many bricks are needed for every square foot the path requires 4 bricks. So I know that there are 66 square feet times, for every one of those 66, I'm going to have 4 bricks. So bricks per square feet. And then when I multiply that together, I get 264 bricks. So that would be our 2 answers that we would need to brick in. All right, let's move on. What will it cost to carpet a rectangular floor measuring 12 feet by 15 feet if the carpet costs $18.50 per square yard? two ways to attack this problem. So I'm going to split my screen, and we're going to attack it both ways. The first way is we're going to draw this rectangle, because I like to see what I'm dealing with here. So I have my rectangle that's 12 feet by 15 feet. And then I'm going to notice something because I'm not going to get tricked. This is in feet, but then it talks about here $18.50 per square yard. Okay, so I'm not going to just jump in with numbers right there because I have two different units. And so for this to work, we have to have everything in the same unit. So I'm going to go with the first one being by feet, and I'm going to go ahead and find the area using feet. So area is length times width. So we've got that 12 times 15, and we get a grand total of 180 feet squared. Now don't jump in there and multiply that by 1850 because 1850 is per square yard. So what I'm going to do here is I know that in a conversion, I know that there are 3 feet is equal to 1 yard. So that also means 9 square feet is equal to 1 square yard. So I am going to divide my 180 feet squared, and I want to convert that into square yards. So I have 180 feet squared. I'm going to divide that by 9, and that gives me 20 yards squared. Now I can go ahead and multiply that 20 times 1850, and I'll get $370 is how much it's going to cost. So on the other side, let's look at it. We still have that same rectangle, same dimensions. But now I'm going to do my conversion on the front end. So that same thing that we wrote over there, we have 3 feet is equal to 1 yard. So instead of 12 feet, if I divide 12 by 3, I end up with, that's really 4 yards. If I divide 15 by 3, I get that that's 5 yards. So I'm going to use the same formula, but now I'm going to use my units of yards. So I would have 4 times 5 would give me 20 yards squared. And then same thing. Now that it's in yards squared and my price is in square yards, I can just do again that 20 times 1850, and we get back to $370 it's going to cost to carpet the rectangular floor. Area of a parallelogram. So let's refresh our memories. Most parallelograms will look like this. So we're used to seeing it where we have our height and our base. Don't get confused and use these numbers as height. Height has to be perpendicular to a base. Hence the reason why we notate with that little right angle right there, that box. And then we know we have the height. So then the formula is A is equal to base times height. So let's give an example here. Let me go ahead and draw us a new rectangle. A new parallelogram. And I'm going to tell you this is 4 centimeters and the bottom is 8 centimeters. So we just plug it into our formula. Base times height would be 8 times 4, a grand total of 32 centimeters squared. Area of a triangle. So the formula that we're going to use coming from the text. Again, the height must be perpendicular to the base, and wherever that perpendicular is formed is how you know you have the base. So we have height and base, the formula being 1/2 base times height. So let's test it out. So we've got one triangle. They're going to put all this jazz on here. 10 meters, 14 meters, 11.8 meters, and then 16 meters. So the only thing that's important to me is finding that base and that height. So I'm going to use the 10, and that's 16. And I'm going to plug it into my formula. So I would have 1/2 16 times 10. Yeah, at this point I would type into the calculator, or I'm just going to do from left to right because all I have is multiplication. So 1/2 of 16 gives me 8. 8 times 10 is 80. My units is meters, so 80 meters squared, or 80 square meters, however you want to say it. All right, let's try another one. Let's do an obtuse triangle. Remember that from my previous one. We're classifying this because we have an obtuse angle. So I have 25.6 inches, 15 inches, 12 inches. But then we have to notate this height because that 15 is not perpendicular. So I imaginary extend out that base of 12. That doesn't count towards our base, and then we measure from the tip point down, in which they did, and they say, okay, that's 9 inches. So again, I go and find the numbers that are important. I'm going to take that 9. It forms the perpendicular with a base of 12. Okay? And then we just plug it into the formula. So remember, you're still using that 12 because that is the base, and then the height is 9. 1/2 of 12 is 6. 6 times 9, 54, and we're inches squared. Area of a trapezoid. Trapezoids are special. They have that height, still the same thing, forming a perpendicular. But then we have a base 1 and a base 2. Those are our pertinent information there. So the formula we have is 1/2 base, let me back up here. 1/2 height times base 1 plus base 2. You might see this notation different. They might call the bases A and B. Basically what you need to remember is that it's 1/2 height times the sum of bases. However they decide to notate them. Just add the bases up, and then you're going to do 1/2 height times that number. So let's take a look at that. So here is our trapezoid. 17 feet, 32 feet, 46 feet, 13 4/10 feet. And then our perpendicular down is 13 feet. So really the hardest thing on all of these area problems or finding stuff with our formulas is making sure you have the right parts. So I like to either draw it and then I want to circle the parts that are important to me. So the height is important and the base is important and then the other base is important. Those other two numbers are just extra stuff. I would use them if I was finding perimeter, but we're not finding perimeter, we're finding area. So I'm going to plug it into the formula. 1/2 13. And then we're going to add our bases. 32 plus 46. You could type all this into the calculator. Make sure you're using your parentheses. 32 plus 46 gives me a grand total of 78. And because I'm not using a calculator, I'm going to take 1/2 of 78 first, which would give me 39. And I'm going to multiply that times 13. And it gives me 507. We're in feet, yes, feet squared. All right, some double trouble here, pulling in some of our tools that we've used before this lesson. Let me paint the picture here. We have a right triangle. That's going to be important. That is 5 inches on the hypotenuse. I know that because it's opposite of the right angle. And then one of its legs is 4 inches. Well, if we were doing this in our last one, we would just be looking for that missing side, but we're not. We want to find area. But remember, the formula for a triangle is 1/2 base times height. So if I go to circle my important information, I have my base, but I'm missing that height. But I can find it because it's a right triangle. Hopefully you're thinking to yourself right now, yes, use Pythagorean theorem. A squared plus b squared equals c squared. Remember, we have the c because that's the hypotenuse. So I don't know, I'm just going to say I don't know a, plus 4 squared is equal to 5 squared. A squared is equal to 5 squared minus 4 squared. So a squared is equal to 25 minus 16. A squared is equal to 9. Take that square root. A is 3. Well, I just found that other important part of information right there I needed. So now I can go back to area and plug in the formula. So 1/2 that 4 times the 3 we just found. Half of 4 is 2 times 3. That would be 6 inches squared. Remember, the Pythagorean theorem only works for right triangles, but you have to have that missing part of information to find area. Don't let them trick you, and make sure you answer the question that they pose to you. Circumference, fancy way of saying perimeter, but we use the word circumference when we're talking about the distance around a circle. Okay, some important parts about our circle. And that was a terrible circle. Let's see if I can try that again. Some important parts about a circle. A little bit better. We've got our center point. A segment that goes through the center from side to side is what we call our diameter. And then if I have a segment anywhere that goes from the center to the side or to the edge, we call that our radius. Okay? So that also means 2 radius make up 1 diameter. So 2r is the same as 1d. Formula for circumference, there's 2 of them. We could do pi times d, or we could say 2 pi times d, because 2 r's make 1, or how about not 2 pi times d? Misspoke. 2 pi r, because 2 radius make 1 diameter. Something that's going to be important here, you need to pay attention. Are they asking you for the exact or an approximate answer? If they ask for exact, then let's say I was doing, we ended up with circumference is equal to 12 pi. Exact would be exactly that. We don't want to type in pi. We don't want to type in 3.14 for pi. We don't want to type in 22/7 for pi. We're going to leave pi as pi in our answer because we're not rounding it. So we would have 12 pi. Approximate would be, they'd ask me or tell me to type in 3.14 for pi. If I approximate, then for that same 12 pi, it would be 37.68 because I typed in 12 times 3.14. So make sure you're paying attention. Are they asking you for an exact answer or are they asking you for an approximate? All right, so let's try it out. So here's our circle. And I'm going to tell you that the diameter is 40 yards. And we want to find circumference. We're going to do exact and approximate. And when we approximate, we're going to do to the nearest tenth. So since they gave me the diameter, I'm going to use the formula for diameter. So I'm just going to plug that in, 40 pi. Automatically, there's our exact answer. Because I haven't done anything with pi. I haven't rounded, I haven't typed it in. I've just left it like that. Now, to do the approximate, I'm going to say 40 times 3.14. And I'm going to get approximately to the nearest tenth. It would be 125.7. And these are all yards. And it's not yards squared because we're not doing area, we're just doing circumference. So just the distance around. So then that would be to the nearest tenth. Okay. So let's turn this into a word problem. So it says, how much trim to the nearest tenth of a foot is needed to go around the window? So here's the window. And I'm going to tell you the window is 8 feet tall here, 6 feet tall here. So we need how much to the nearest trim, to the nearest tenth. We're talking about trim. So trim tells me right away we're talking about perimeter. I have two shapes. So let's just say I started marking this and I started here at this corner. When I measure here, I have 6 foot. So I'm going to start working on this perimeter. So I'm going to have 6 plus, I'm going to go up. I have 8. If I continue around here, that's the part I don't know. So I'm going to just put a question mark. But I know if I continue down from here down, that mirrors the other side, which is that other 8. And now I'm back to where I began. So how can I figure out this? That's the question here. How can I figure out that? Well, that's half of a circle. And I know by looking, I know by looking at the bottom that if I drew this imaginary diameter here, it mirrors the bottom, which is 6 feet. So I have a tool, circumference is equal to pi d. That's if I want a full circle. So if I only want half a circle, let's just go ahead and cut that formula in half. And let's plug in what we know. So we know pi times 6 divided by 2. 6 divided by 2 is 3. So that orange is 3 pi. But it already told me to the nearest tenth, so I'm going to type in 3.14 times 3, and I get 9.4. And we're talking about feet. So now I know that orange distance is 9.4 feet. So I go back to my equation where we already started this. 6 plus 8 plus, I know that now, 9.4 plus the final 8 to get me all the way around. Let's type in the calculator, add it up. 6 plus 8 plus 9.4 plus 8 gives me 31.4 feet. All right, let's jump in. So I had alluded to area of the circle because we were talking about circumference. Area of the circle is pi radius squared. So same thing. They give you the diameter. Well, now it's important that you only focus on that radius. We only need that r for the area formula. So let's try one real quick before we jump into that word problem. So if I tell you I have a circle that's 16 inches in diameter, your first thought needs to be, okay, I need that radius. So I cut the diameter in half. 16 divided by 2 gives me 8 inches. So now I know radius is 8 inches. We're going to plug it in. And we're going to have area is pi r squared. So pi times 8 squared, which would give me 64 pi. Okay, so I did that first pizza right there. If you look at that. That first pizza has a diameter of 16. So let's go ahead and do the second pizza. The second pizza has a diameter of 8 inches. So I want that radius, so I cut that 8 in half and I get 4 inches. So radius is 4 inches. Area is equal to pi r squared. Pi times 4 squared. Pi times 16. Well, let's just go ahead and, let me go ahead and do this. So that just gives me 16 pi. All right, so now we have the area of both of those pizzas. So that's 16 pi inches squared. Let me go here and stay true and keep my units on there. But they don't just ask me for that. They said, what is the better buy? So I have to think about the first pizza, the large, it costs $15. And we're going to divide that by that 64 pi. So this is where you definitely want to type it in the calculator. Use that fraction button. Type it in there just like it looks. So 15 in the numerator and 64 pi. Make sure it all stays in the denominator. And then you're going to get, we're talking about money. So since we're talking about money, that means we're rounding to the nearest hundredth. So we're going to get that it's cost 7 cents for the large per inch, 7 cents per square inch, okay? So same thing on the medium. We're going to take that 750 and we're going to divide it by my 16 pi. And then we're going to type it in the calculator to the nearest hundredth and we're going to get it's 15 cents. So the better buy, go on with the large. We're just basing it on money. All right, guys, I appreciate your hard work. Keep it up. Let me know if there's anything I can do.